Now, when I have a no start, no spark electrical issue where the bike just won't run, I'm not really sure what's going on with the vehicle itself, probably the first thing I'm going to do is I'm going to check the ignition system. And the first part of that ignition system I'm going to check is going to be the CDI unit. Basically, all the CDI units, it just interprets a fire point signal from the pickup coil, introduces it to the CDI unit. The CDI unit in return will transfer a power pulse to the ignition coil, delivering the spark to the spark plug itself. So if you're having a, well, no spark issue with your Madass, and obviously it will not start that way or run, what I basically do is first I'll remove the spark plug from the engine itself so I have no compression running through the engine as I'm trying to turn my flywheel. I also want to turn my flywheel to top dead center, and I want to get it on the compression stroke because I don't want to have it on valve overlap. You can easily tell this just by bringing it up to either the fire point or top dead center, and you should be able to move your flywheel back and forth very, very easily. All I really want to do is to have this tab pass through the magnetic pickup coil, or you can call it a pulse generator, because we want to make sure that this signal or the communication from this pulse generator is getting to my CDI unit. My CDI unit is interpreting that pulse and it's sending an actual charge or a timed pulse charge to the ignition coil. So it's simple to test this. You can actually do it with just with a test light itself, and I'm not sure you're going to be able to see this because of the light that I have here, but you can just take a simple test light. Now, because we're going to be testing a power pulse, we want to take our connector or the little clamp and we want to bring that to a viable ground. Something that's constant, something that's not a switched ground, something that has constant ground to it. The other end of it, I'm going to probe right into the back of the connector while the connector is connected to the CDI unit. I'm going to do the normal thing that I would normally do as I would start my bike. I want to put the key to its on position. I want to make sure the kill switch is set to run. And all I'm going to do is I'm going to rotate this back and forth very quickly, and I want to do it, and I want to be able to see some type of a light pulse coming from my test light. So if I do it very quickly, I don't know if you can see that or not, but my test light is pulsing. Okay, this is telling me that my pulse generator is working correctly, my CDI is working correctly, and at least it's sending out a power pulse to the ignition coil. If all this is working, I don't even need to mess with this any longer. I go directly to my coil after that. But just for an example, say if this was not pulsating the light, then I need to start checking the connectors going to the CDI unit itself. So we don't want to condemn the CDI unit just yet. We want to make sure all the properties are being introduced to the CDI unit. In order to do that, we need to test a couple things. The most common issue is going to be a ground issue to the CDI unit. It really kind of all lacks to that stupid kickstand switch. Now on the back of the connector, now we have the connector disconnected, so all our testing is going to be at the open end connector itself. So if I'm going to be testing ground, what I want to do is I want to take my test light clamp and I want to hook it up to a power lead. So I just have this test lead right here. It's connected to the battery, or at least the positive side of the battery itself, and I want to connect these two together. So now my test light has power. To complete this path, now I'm going to be probing into the back of this to where the green wire comes out. And you can't really look at the wires that I have on this because this connector really is not the stock connector. This is probably, I don't know, I think it was from like a stereo or something like that. I just found it in my toolbox, and it had the right slot configuration for my CDI unit, so I went with it. So this is going to be where your green wire comes from. It's going to be your ground wire. When I probe into this, I should have light from this, and so we're good. If you can see the light there, we're going to be okay. That means we have a good constant ground. Now if the light didn't come on, then I would start messing around with my kickstand switch if I still had one. If you want to eliminate the kickstand switch, all I would do is take that green wire, make sure I have enough lead here to come off of it, and I probably would cut it and just splice it to some type of a constant ground so it wasn't a switched ground any longer, and that seems to work out pretty well. Now the other thing you might want to check on that is if you have good ground to it, you want to make sure you're getting power to the CDI unit. On the connector itself, I'll have a black wire going into the CDI connector. This is going to be a switched power wire. This should only have power when the key is on its on position. So now that we're going to be checking power again, we want to take our clamp from our test light and we want to connect that to, again, a constant viable ground. We want to find our black wire lead right here, and so right now we have no light, and the reason being because our ignition switch is in its off position. So the ignition switch has to be on the on position. So if we turn on our ignition switch, we have light. We turn it off, we have no light. So that means we're actually getting power to our CDI unit. So our ground is good, our power is good. Now we need to check, and we also know we have a good pulse to this as well. So if any one of these items fail on there, you need to find out why. If you don't have power going to your connector itself, why do you not have power going to your connector? You would have to follow the lead all the way back up into the ignition switch, or where it splices into the ignition switch, and find out where the breach of power is. Same thing with the ground. If you don't have ground, or a constant ground going to your CDI unit, the whole system shuts down. It all fails. Now with our pulse generator, or you can call it a pickup coil, or you can call it a crank position sensor, it all does the same thing. All it's really doing is delivering some type of communication, a fire point, to the CDI unit. The CDI unit will interpret that fire point and it send out a power pulse to the ignition coil, delivering the charge to the spark plug itself at the precise time. A couple ways you can check your pulse generator. You can go through the long series of, removing the cables from your battery and doing an ohm test on the pickup coil if you want to spend that type of time. There's a couple real simple ways to test your pulse generator just to make sure it's operational. First thing I would probably do is I want to make sure that I have good ground going to the pulse generator. The upper wire, which is going to be your green wire, is going to be a ground wire. It actually loops all the way behind the actual flywheel here and actually attaches to the back of the stator. So that is your ground. As long as that stator is tight to the engine itself, and that wire is tight to the stator, then you should have a good constant ground. That basically means that this will always have ground. So all I'm going to do is, since I'm going to be testing ground, I want to attach my connector to my test light to constant power. So now that this is energized, all I'm going to basically do is take my test light probe and I'm going to go directly into where the green wire is. And it's going to be hard to get it in there so you guys can see, but you can see it's lighting up. So there I have good constant ground. Now the blue wire is a little bit more difficult. The blue wire is actually what delivers that communication to the CDI unit. But it has two paths. It actually has one path that goes to the kill switch that's on the right side cluster. So when the kill switch is in its on position, this blue wire should have no ground to it whatsoever. So while my connector is still connected up to power, I'm going to take my probe and I'm going to go to the blue wire, and we have no light. Now, if I was to take my kill switch and I was to turn to its off position, now I have light. So all that's basically doing is throwing my pulse to ground. So off is good, on is bad. Well, on could be good just as long as you have your kill switch in its off position. But if your run switch is in its run position, we want to make sure the light is off. Another way to test your pulse generator, just to make sure it is sending some type of communication to the CDI unit, this can be done with a multimeter. Probably a little bit more precise way to look at it, but all you're really going to basically do is you're just going to be looking for some type of voltage spike. So I'm going to set my multimeter. It doesn't really matter. I can set it to DC volts or AC volts. It doesn't really matter, because all I really want to do is I want to see some type of communication. So all I'm going to do is I'm going to take one of my leads and I'm going to go directly to where the blue white wire is, and I'm going to connect it. I'm going to take my other lead and I'm going to go to a viable constant ground. And see if we can get a look at this. But if you can see that right now, it's going to be at 0 because there's no current flowing. Now, if I take my flywheel, and remember what we want to do is we want to take that tab and we want to make sure it passes through the pulse generator. But if I move it back and forth, you can see I have activity. That's telling me that there is some type of communication coming out of the pulse generator. And then we just need to make sure that that pulse is getting to the CDI unit.